All right, so we'll go over MIDI. Basic overview, talk a little bit about it, a little bit about the prehistory. Then we get into the MIDI spec. And the spec is kind of two-part. There's hardware, and then there's protocol. And then we'll talk about files. And, you know, MIDI files are the .MID files. And, well, how are those related to, you know, these cables and devices I brought in? We'll see. Okay, so first off, hardware. Pre-MIDI. Now, it's kind of like one of those things when your older professor tells you about the analog computer. You talk about the musical, you know, what is MIDI? It's a musical instrument digital interface. And just like analog computers, there were analog interfaces, you know, and they had obvious problems. I mean, the one option was this CD and gate system they called. What they would do is they'd say, okay, you've got a control voltage, and that control voltage would correspond to a pitch. So the system they used was 1 volt per octave. So you had 83 millivolts per semitone. And then there was kind of a wake-up pulse to tell you when to start the pitch. So you wake up with some 5 volt pitch, then you hold some constant voltage, and then when that disappeared, it would be over. And that kind of worked. Obvious problems, it's a voltage-based system, so there's a lot of resistance in the cable. All of a sudden, you know, your far-end synthesizer is playing a half-step level. It could tend to sound a little bad. Misses a wake-up pulse or any usual kind of stuff. But then the other problem is, of course, you get 1 pitch per cable, right? So if you wanted something that was polyphonic, you'd have to hook up several different cables in order to get several different pitches, because you're just talking about DC voltages, right? So this was, you know, late 70s, early 80s technology. MIDI came on, I don't have the year here, I believe it was the early 80s. The idea was to come up with a standardized way of connecting instruments. So musical instrument, digital interface. The idea originally was to synchronize the 2 machines for live performance. So for instance, like this machine, well, strictly a MIDI controller, and then this machine, this drum machine, is strictly a MIDI sound bag. So you can program the drum machine via the keypad, and it can have stored programs, or you can control it from this keyboard. Now, if this was a full synthesizer instead of just a controller, it would have its own sounds, and it could still do control another device. So it was a nice thing that really, you had only a limited way to deal with analog, right? Because there was only that monophonic. The other nice thing was, again, thinking back to pre-80s, you know, nowadays we take for granted we've got hard disk recording, we've got gigabytes of RAM, and it's easy to do recording at home. Back then, when, you know, 64 kilobytes of data was a lot, MIDI was great because it was a very low overhead way of recording music. You know, especially if you're a keyboard player. You could just record everything, it would get stored to a very compact binary file, and then you could play it back later. And there are a lot of devices that were, you know, they're almost worthless at this point, but they were very common MIDI sequencers, where it was basically a device with a lot of memory, programmable memory, and you would play into it, it would record the song, and then you could play back from it, and it was a MIDI sequencer. Nowadays, they make keyboard sequencers built in on the standalone sequencer has died because a computer is a lot more useful for that. Okay, so one thing is you can, not only can you have polyphonic systems, but you can actually have 16 different channels on the cable. So if you daisy chain 16 different devices together and they're each on their own channel, they could all work over one set of MIDI cable. And we'll see how that works. Okay, so the MIDI spec, which unfortunately I don't have a copy of yet that you need to purchase, is includes both mechanical, electrical, and then the data format. Still trying to see if I can get a copy as an educational institution. Should look into that. It could be handy to have on hand. We've gotten other things. Like I actually got the library to order a vacuum tube manual. Oh, cool. So It would be useful. I wish it was there when I was a student. The MIDI cable. Basically, it's this big, what they call a 5-pin DIN, you know. Used to be the most common use for this was a keyboard on a computer.
Oh, yeah, yeah.
Before the PS2 connectors, they had these, but they actually MIDI kind of predated that. MIDI came out really before the IBM PC dominance. So there are 5 pins. The center pin is ground. The other 2 are for the current loop. We'll get to that. And then the other 2 are unused. So they spec the 5-pin cable originally, and then they never actually used the last 2 pins. Very often, those last 2 pins are used as power. Because if you look at certain, we'll talk a little bit about guitar rack mount units. They'll use MIDI for control information. So even though the signal processing path doesn't involve MIDI or doesn't involve nodes or synthesizers, it will use the patch change information to switch patches so that you get the different guitar sounds. And then a lot of times what they'll do is they'll run the data over MIDI because the foot pedal selector is strictly a MIDI controller, right? It doesn't need input, it just gives output. And then, so it only needs the 2 wires. And then it has power over it so that you can run just one cable in the foot controller. So that's kind of a common but non-standard use for those other 2 pins. There are some other controllers too, like I have a PD one where instead of requiring you to use 2 MIDI cables, because the MIDI cable is unidirectional, instead of requiring you to use 2 MIDI cables like most MIDI devices would to get bidirectional connectivity, they actually went to an 8-pin MIDI cable, which was non-standard. Only PD did it as far as I know. Other companies might have done their own non-standard ones, but there's not a standard bidirectional MIDI cable. But that's useful because then the footboard actually tells you the name of the presets. Okay, so how does the MIDI work? As you probably noticed, I didn't say that this pin is a signal and this pin is, these pins aren't voltages. They're both labeled as loop pins. So what happens is MIDI is what's called an old current loop technology. Hear of current loop? It was a very old serial protocol. The idea was that instead of running a voltage somewhere, you would use the current in the line to light something or to drive something. So instead of having, in a normal voltage-based system, you'd raise the voltage and you would have some kind of detector, TTL or whatever, to determine whether it's logic high or logic low. Well, instead of that, with MIDI, what it does is the controller is basically an open collector transistor, where the collector is tied to the cable is run to the other device, and then the other half of the cable goes back, and that goes to plus 5 volts. So what happens is when you turn this on, the current flows through and it lights the LED. Now the LED is part of an opto-isolator, and that has the phototransistor, which picks up whether or not it's emitting light. You see phototransistors?
Yeah, yeah. On the project, we haven't
Okay.
work out separately because they all have to be calibrated. Yeah.
Yeah, these kinds of things are actually used in a few different, or similar type things are used in a number of ways in music electronics. Like, this is an opto-isolator, and I'll explain why we use it. But also you see a similar device in a phase shifter pedal. And what that is, instead of using a phototransistor, they use a CDS cell. It's cadmium disulfide, I'm not sure about it. CDS is a variable resistor where resistance changes based on light. And so it's a nice way of coupling something from one circuit to another. It's also used in tremolo very often, in amplifiers. So you've got a light source that varies periodically, and you've got a resistance that responds to that. So here, we've got a light source that varies with the MIDI data, and a phototransistor that responds to that. And if there's a logic 0, current flows. If there's a logic 1, no current